Alright, chemistry, this is your video lecture for chapter 2, section 2. We are going to be talking about units of measurement and measurement. Distinguish between a quantity, a unit, and a measurement standard. And I want you to be able to name SI units for length, mass, time, volume, and density. So here we go. So measurements. You make a measurement every time you measure your height, read your watch, take your temperature, or even weigh a cantaloupe. But in chemistry, we measure quantities, we do experiments, we calculate results. We use numbers to report measurements, and then we compare those results to standards. So in a measurement, a measuring tool is used to compare some dimension of an object to a standard. For example, these calipers over here are measuring the thickness of the skin fold at the waist. For this, we use these calipers. When we go to state a measurement, there's a very specific way we do this. In every measurement, a number is followed by a unit. Observe the following examples. So we have a number and a unit. For example, 35 meters. That's a number and then a unit. 0.25 liters. That's a number and a unit. 225 pounds. That's a number and a unit. 3.4 hours. Again, a number and a unit. When you have a number and a unit together, it is known as a quantity. So the metric system, aka the SI system, and that stands for international system, but it's in French, so they're flipped. That's why it's SI instead of IS. It is a system that is based on the number 10. It's a decimal system, and that makes that a lot easier for calculations. The SI system is used in most of the world. Only a very small number of countries still use anything but the SI system. Just so happens that the U.S. is one of them. However, by essentially every scientist, the SI system is used regardless of what country they're in. So in the metric and SI systems, one unit, and by the way, they aren't the exact same thing. They're just highly, highly related, the metric system and the SI systems. One unit is used for each type of measurement. So when we're measuring length, in the metric system, we use the meter. In the SI system, we also use the meter. For volume, in the metric system, we use the liter. In the SI system, we use the cubic meter. They both measure volume. They're just different units. For mass, the metric uses grams. The SI base unit for mass is kilograms. Both systems use seconds for time. Metric system uses degrees Celsius for temperature, whereas the SI system uses Kelvin. So looking at length. Length is measured using, for example, a meter stick. It uses the unit meter in both the metric and SI systems. Now, for future reference, we will be using the SI system in general for the rest of this course, but it is nice to be familiar with the metric system as well. Inches and centimeters. Now, the unit of an inch is equal to exactly 2.54 centimeters in the metric or SI systems. Now, this isn't rounded at all. By definition, and this is going to be important later, by definition, 1 inch is equal to 2.54 centimeters. Temperature is something that actually measures the kinetic energy of a substance. And again, kinetic energy will be something that we'll cover in more depth in a later chapter, but it's the amount of motion present in that substance. Temperature is measured on the Celsius scale for the metric system and on the Kelvin scale for the SI system. And over here on the right, we see a picture of a thermometer showing both degrees Celsius and degrees Fahrenheit. Time uses the unit seconds in both the metric and SI systems. It's based on an atomic clock that uses a frequency that is emitted by cesium atoms. Now we have those basic types of units, but we also have what is known as derived units. For example, a base unit is meters. That's length. It's just m. But when we multiply or divide any base units by other base units or itself, we consider that to be a derived unit. So, for example, volume is a derived unit because we are taking the length, meters, and cubing it. Density, we're taking a mass, kilogram, and then dividing it by volume. Again, we're dividing it by something. Speed is meters per second. Again, length divided by time. That's derived. A Newton is a little bit more useful in physics, but it's mass times length divided by seconds squared. Energy, joules. Again, that is mass times meters squared divided by time squared. And then we have pressure, pascals, which is mass divided by length times time squared. Okay, so all of these involve some sort of calculation, some sort of division or subtraction of more than one base unit. And we consider these derived units. All right, that's going to finish it up for this portion of the video lecture. We will finish it up next time we meet. I will see you next period.